Hello, now let's study the curvature, the second part of this section, curvature. So before that, I'm going to draw the graph and let you see the difference between those two graphs. Okay, curvature. Let's take a look. If I draw graph like curve, look at it like this way, and the other one look like this. Can you see the difference? So actually, you can see those two curves, they turn like the first one turns slowly and the second one turn quickly. It's like when we drive on the road. So sometimes we have a big turn, we turn small angle, right? So actually, what is curvature? Curvature means, here I'm going to give you the definition. The curvature of a curve C of C means a curve, okay, at a given point is a measure of how quickly the curve changes direction at that point. Is a measure of how quickly the curve changes direction. Okay, at that point. So that's the meaning of the curvature. But how to find the curvature? By use mathematics. Okay, now let's take a look. Here, this curve, we have a tangent vector, or unit tangent vector. And here we at point, we have this unit tangent vector, right? And you can see if after the same time period, okay, so for example, for this arc length, okay, and our tangent vector is here. And for this, like same length, for example, same length, our tangent vector become here. So you can see that means how to tell the curvature. We can find the rate of change of the tangent vector. So you can see rate of change, this is larger, right? Larger rate of change of t, or large change of t, and this is small, t changes slowly, right? T changes slowly. So what's the meaning of curvature? That means the rate of change of the tangent vector respect to s. So it's like delta t over delta s, something like that. When we have the same like arc length, how fast the tangent vector change. Okay, so that means this one. That means the rate at which t turns per unit length. So that just means the rate of change of the tangent with respect to arc length. Let's see. How do we calculate dt ds? Okay, dt ds. The curvature is defined to be, let's see, I'm going to give you the definition. So let's see definition. If t is the unit vector, tangent unit vector actually, vector of a smooth curve, and the curvature of the function is this one. Of the curve is defined to be this. K equals the rate of change of t with respect to s, and we take the length. And here t is the unit tangent vector. Okay. So the meaning means the rate of change of tangent or direction of the motion with respect to the arc length. Next, let's take a look how to calculate the curvature. Okay, how to calculate the curvature. So this is the definition for the curvature. The calculation, let's see, we're going to do it this way. So we introduce dt, small t, okay? So dt ds equals dt ds, right? Same thing, because we can, if we just cancel the dt, you know, they are the same thing. Right now, let's take a look. And we are going to rewrite this as dt over dt and divide by the reciprocal of our second term, so which is ds dt. Capital D over dt, that means just like a second derivative kind of our RT, because t is the tangent vector, which is the first derivative, and then we take another derivative. So this is easy to calculate, right? And next, let's see what is ds dt. ds dt, think about what the meaning of this one. That means the rate of change in the arc length. So in the last section, the same section actually in the last class, we learned this is 0 to t, and here r prime tau d tau, right? And the ds dt actually is what? By fundamental theorem of the calculus, that is r prime t and length. So actually we can change the denominator into here dt, we write down this on the right side, okay, and 1 over ds dt is the length of r prime t. Okay, so this is the formula for the curvature. Or sometimes we can just write down like this way: t prime over r prime. Okay, so maybe this is easy for you to know. Okay, now let's take a look at the definition. So this is the calculation, the formula, how to calculate the curvature. This is the formula for curvature. Now let's take a look at the example 3. Show that the curvature of a circle with radius a is 1 over a, okay, reciprocal of a. Now let's see. Firstly, for the circle, definitely for the curvature we need the vector function, but here we just know the circle of radius a, right? So firstly we need to set up RT, and the circle is in 2D or 3D. It's in plane, so it should be in 2D. So we just have I and the J component. So it should be, and also think about the polar coordinate. How to set up the parametric equation for the best parametric equation for a circle? Like a cosine t sine t, right? So we can say a cosine t, because the radius is a cosine ti, a sine tj. So firstly, we set up the parametric equation for the circle of radius a. Now this is RT. And next, in our curvature, what do we need? We need a t, tangent unit vector. Okay, so we need this one. Next step, let's find this one. how to find the t, that is r prime. So r prime equals negative a sine t I a cosine t j. Is that right? And what is capital T? Capital T is called unit tangent vector. So it is a unit vector. So we need to divide by the length of r prime. So the length of r prime, which is a square sine square, a square cosine square, so which is root of a square, and it is a. Is that correct? So let's see what is our t. Actually, the t equals r prime t divided by the length of itself. Okay. So divide by a, so just negative sine ti plus cosine tj. So first step, we calculated t. Is that right? And next, we need to find the derivative of this t, capital T. Look at our curvature formula, capital T, derivative, so which is negative cosine ti minus sine tj. Is that right? And next we need the length of this vector. So the length of the t prime, cosine square t, sine square t, which is 1. And the r prime t, we already get that from here, which is a. So k equals t prime derivative over r prime length, so which is 1 over a. So we just prove that. So think about here, for example, we have a radius like this is radius 2. Okay, here we have a circle with radius, we say that is 4. This is 4. Okay, so you can see who has the larger curvature, and the curvature for this one is 1/2, and curvature for this is 1/4. 1/2 is greater than 1/4. Is that right? So this, the first circle, circle 1, circle 2. So circle 1 has larger curvature, and the circle 2 has smaller curvature. That means you can also see from the graph, the first circle turn quickly, and the second one turns slowly. Right, that's the curvature. Let's see, I may have one exercise for you. Let's try this. RT is given, which is Ti cosine Tj. Now let's find the curvature of this. Here's the solution. Think about the formula T prime over R prime length. So firstly, let's calculate R prime. 1 plus 1 over cosine t, and derivative of cosine chain rule, negative sine tj. And if you rewrite this, this is 1 minus tangent tj. Is that correct? Okay. Next, let's calculate R prime t length. Root of 1 plus tangent square t. And here we need to know the identity. 1 plus tangent square, which is secant square, and which is secant t. Okay. Next, let's calculate t. T equals R prime t over the length of R prime t. So which is 1 over, sorry, here should be I should be 1 over secant ti minus tangent t over secant tj, and simplify this. 1 over secant should be cosine ti, and the tangent is sine over cosine, and then over 1 over cosine, so should be sine tj. And next we need to calculate t prime. T prime should be negative sine ti minus cosine tj, and the t prime length is 1. So our curvature, we have all the information we need now. Curvature equals t prime length over r prime length, which is 1 over r prime length is secant t. So the final answer is cosine t. The curvature is just cosine t. So here the curvature is a function, right? That means definitely for a curve at a different point, it has different curvature. So this is different from circle. For the circle, it has curvature, same curvature at anywhere, at any point. But for some lengths, some may look like this, or maybe turn quick, or turn slow. So that's a function of t. Okay, so the curvature is a function of t. There's another way to calculate the curvature by using the formula. So let's take a look. As given by the theorem, the curvature of the curve given by the vector function is given by this way. So it's going to be the cross product of r prime t and second derivative of r, and divide by r prime t length cube. Okay, and here we skip the proof. The proof is kind of complicated. We don't need to know, and we just need to know the formula. And in the exam, the formula will be given. Okay. So now let's take a look how to calculate curvature by using this formula. So example number 4. Let's take a look. Right now, we want to find the curvature of this RT. And it's given by t squared t cubed at a general point. And at so this means we want to find the general formula for the curvature and then plug in the point 0, 0 to find the curvature at that point. So now we want to use the formula. So the first thing we need to calculate is the first derivative. It's pretty easy to see from here. 1, 2t, 3t squared. And then calculate second derivative. So which is 0, 2, 6t. And then we calculate the cross product. And the cross product equals determinant of 3 by 3 matrix ijk. So here r prime 1, 2t, 3t squared, 0, 2, 6t. Okay, so something like this. Now let's do the calculation. For the s component, it's going to be 12t squared minus 6t squared, so 6t squared I. And for the j's component, you can see it's going to be just 6t, but it's minus 6tj. For the k's component, should be 2 minus 0, so it's just 2k. Not difficult, right? And for the curvature, what do we need? We need the length of this one. So length of this cross product. So which is square root 6t squared squared, 6t squared, and 2 squared. And simplify, that's going to be root of 36t fourth plus 36t squared plus 4. And we can factor 4 out. So it's going to be, and when we factor it becomes 2, right? And when we factor 4 out, 9 left. You don't have to simplify, but this is simplified form. And then now let's take a look at next. In the formula, we also need an r prime length. So that's the derivative, first derivative length, which is 1 plus 4t squared plus 9t to the fourth. Okay, and now we just plug into the formula. So which is, okay, I'm going to write down the formula again. Cross product, first derivative, second derivative, and first derivative length and the cube. So which is 2 9t to the fourth plus 9t squared plus 1, and here which is root of 1 plus 4t squared plus 9t to the fourth and to the third power. Okay, so yeah, we can just leave the answer like this. And then now we are going to calculate the when. So we need to know the point is given. We need to know what is t, right? So by looking at this point, so if we look at the point, that means t equals 0, because when we plug in the point into RT, we can see t is 0. So actually we're looking for what? K0, the curvature. So we just change all the t into 0. So the final answer is 2. So the curvature at the point 0, 0 is 2. Okay, and this is all about the curvature. Next, we're going to learn normal vector. So what's a normal vector? So for a given curve, we know there is, for example, at this point P, there is a tangent vector, right? So this is T. And the normal vector means the vector which is perpendicular to the T. So something like this. Okay, we call that normal vector. And for the normal vector, how to do the calculation? We are going to use the conclusion in 13.2. Let's take a look. 13.2, example 3. Let's take a look here. Look at here. If the length of the vector is a constant, then the derivative of this vector is orthogonal to this vector for OT. So that means if the length is constant, then derivative is orthogonal to the vector. And then now let's take a look at how to find the normal vector. Firstly, let's think about t vector. T vector is r prime divided by the length of r. It's called a unit tangent vector, right? Unit tangent vector. And what's the length of this t vector? So this is 1. So definitely this is constant. So the length of t is constant. That means 13.2, example 3. If the length of this vector is a constant, then this vector perpendicular to its derivative. Okay, then how to find the normal vector? So normal vector is the vector that's perpendicular to the vector t. So we just choose this vector to be the n vector. But we, same as unit tangent vector, we want this to be the unit vector. So we just use the t vector divided by its length. And that's the definition for the unit normal vector. Okay, so let me give you the definition. Definition 2. It's called the principal unit normal vector, or sometimes we just call that unit normal vector. NT. Okay, and then now let's see how to calculate this NT. That equals t prime. Okay. because perpendicular to that one, but we need a unit vector. So divide by its length, something like this. Okay, that's the formula for the normal vector. So for this one, we don't need to memorize, we need to understand. Now let's take a look at the example. Find t and n for the circular motion. And this RT is given by cosine 2ti sine 2tj. Okay. So firstly, how to find the tangent vector? Tangent vector, we just take the derivative, right? So I'm going to write down this way. Take the derivative cosine should be negative sine. But because we have true rule times another 2, I'm going to write down the component form. I like to see this. Okay, r prime t. And how to find the t vector? We need the length of this vector, which is 4 sine squared, 4 cosine squared, and it's just root of 4 after simplify, so which is 2. So what is the unit tangent vector? So which is just use the r prime t. I can write down the formula again. So r prime t divided by the length of r prime t, which is just a negative sine 2t, negative positive cosine 2t. Okay, just use the rt divided by the derivative, the length of the derivative. Next, let's take a look at how to find the normal vector. So the normal vector equals t prime. So I'm going to write down t prime. So look at t. We have t here. T prime derivative of this one, so should be negative 2 cosine 2t, negative 2 sine 2t. And the same thing, we need the length of this t prime, so which is also 4 cosine squared, 4 sine squared, and which is 2. And so the normal vector equals to t prime over t prime length, which is negative cosine 2t, negative sine 2t. So this is the normal vector, and that is the tangent vector. Okay, so pretty easy to calculate. Now let's take a look. Here I have the exercise for you, and then let's see. You can try. RT is given by Ti natural log cosine Tj. Let's find T and N. I will give the solution later. Now let me give the solution. But I want you to try by yourself. R prime 1 cosine t times derivative of that one should be negative sine chain rule. After simplify should be 1 negative tangent t. So why I want to change it into tangent t, because later we'll take the derivative and it's easier to see this way. So the length of this one should be root of 1 plus tangent square, which is secant square, which is just secant t. So the capital T just equals 1 over secant t negative tangent t over secant t. Simplify. Secant t is 1 over cosine, so 1 over 1 over cosine should be just cosine t. Here sine over cosine over 1 over cosine should be just sine. Right, and next we take the t prime. T prime should be negative sine, negative cosine, t prime length, which is 1, so the n equals just this. Negative sine t, negative cosine t. So this is the n vector, normal unit vector, and that is the tangent vector.